8.2b is on writing equations of a parabola. So we've already looked at things where we had an equation in slope or in intercept form and we used it to graph our parabola. So today we're going to do that backwards. We're going to have our parabola and we are going to use it to write our equation. So in order to write our equation in this slope-intercept form, we are going to need to find three things. We need to find A, P, and Q. Those are the three things we need to find in order to write this slope-intercept form. Well, P and Q, remember P and Q are just our x-intercepts. So in order to do that, all we need to do is look at our graph. So looking at our graph, we have the x-intercept of 0 and the x-intercept of -2. So we already found our P and our Q. And it doesn't matter which one you have be P and which one you have be Q. You could flip those around if you wanted. You'll end up with the same answer in the end. Then, after you have P and Q, we still need to find A. So let's look at what we have with P and Q plugged in there. Instead of x minus P, we'll have x minus 0. Instead of x minus Q, we'll have x minus a -2. Well, minus a -2 is really just adding, so I'm going to rewrite this as y equals A times x minus 0 times x plus 2. Notice how we still have to find A. And in order to do that, we need A to be the only variable. So since x and y are other variables, in order to do this, all we need to do is find another point from our graph. So I'm going to pick a point that's not my x-intercepts. And I could pick any point on my graph. Pick a nice point, right? So like this point right here wouldn't have nice numbers you could plug in. 1, 3 would be a good option. Let's see, -3, 3 would be a good option. I'm going to use the vertex. I'm going to use -1, -1. And you could use any of these points. You would end up with the same answer in the end. But by using this point, it gives us an x value and a y value. And if we have an x value and a y value, we can plug that in to our equation here. So instead of y equals, we'll have -1 equals A times -1 minus 0 times -1 plus 2. Well, if we figure that math out, -1 minus 0 is just -1. -1 plus 2 is 2. -1 times 1 is -1. If -1 equals -1a, we can divide on both sides, and we will find that our a value is 1. So we found our a value, and we found our p and our q. So we can plug those all into our equation. Y equals 1 times x minus 0 times x plus 2. And then we want to write them as a quadratic. So our last step is just to distribute. So we're going to multiply this out. Well, x minus 0 is really just x. So when we distribute our x, we end up with y equals x squared plus 2x. And that is our quadratic. So this is how we use intercept form to write a quadratic. Here's a list of steps just to break down what we did. We found P and our Q from our x-intercepts. Then we used another point to find A. Then we rewrote our slope and our intercept form using our P, our Q, and our A that we found. And last but not least, we just distributed to find the equation of the parabola. So let's practice a couple more, and we're going to follow those same steps. So for P and Q, well, here's our x-intercept of -3. And here's 1, so I'm going to let P equal -3, and I'm going to let Q equal 1. So x minus a -3 would just be x plus 3, and x minus 1 would just be x minus 1. Well, we still need to find A, so I'm going to pick a different point. Well, they already found the vertex for us, so I'm going to let -1, 2 be my extra point, so I know that x is -1, and y is 2. So we're going to plug that in. So instead of y equals a, we're going to have 2 equals a times -1 plus 3 times -1 minus 1. And then we're just going to solve for a. -1 plus 3 is 2. -1 minus 1 is -2. 2 times -2 is -4. We can divide both sides by -4 to figure out that our a value is -½ We found our a value. We found our p and our q. So we would have the intercept form of -½ times x plus 3 times x minus 1. And then to write this, we just need to multiply. So we can use our FOIL or our box method. So we're going to do x times x would be x squared. X times -1 is -x. 3 times x is 3x. 3 times negative 1 is negative 3. Well, we can combine our like terms, so we would have x squared plus 2x minus 3, and then we just need to multiply everything by a negative half. So y would equal negative half x squared minus 1x plus 3 over 2, which you could also write as 1.5. And this would be our equation for our parabola. So again, notice how we're following those same steps each time. Let's practice one more. It'd be a good idea to pause and see if you can solve this one using those steps. Looking at this one, notice how it's just got this 1x intercept. So for this one, p is going to be 2 and q is going to be 2. So when we plug that in, we'll have a equals x minus 2 times x minus 2. Well, we can use a different point. Notice how since our x-intercept was our vertex, we can't use our vertex, so I'm going to use this other point of 0, 4. 0, 4 gives me the x value of 0 and the y value of 4. So I plug 4 in for my y, I plug 0 in for my x's, which leaves me with 0 minus 2 is negative 2, 0 minus 2 is negative 2, negative 2 times negative 2 is positive 4. We divide by 4 on both sides, so a is equal to 1. So we found our a value and our p and our q. Putting this together, we have y equals 1 times x minus 2 times x minus 2. And then again, we can use FOIL or our box method to multiply this out. Well, x times x would be x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is negative 4. Combining our like terms, we have y equals 1 times x squared minus 4x minus 4. Well, when we multiply by 1, nothing's going to change. So our equation for this particular parabola right here would be y equals x squared minus 4x minus 4. And that is our answer. So in order to graph these, you are just following these steps in order to find that equation.